Hi everybody, so this is Circuit Analysis 1. I'm going to explain everything for this series circuit. We have a 25 volt battery and we have 4 resistor values. We're going to get E total, R total, I total, and all of this, the voltage drops and the power for all of the resistor values, and then we're going to get voltage A to B. So the first thing we see is E total. There's one battery. So E total, which is the voltage applied, is 25 volts because there's a 25 volt battery. So E total is 25 volts. R total would be the next one. How do we get R total in a simple series circuit? Is we add the resistors. In the calculator, we just simply put 1K, so exponent 3. Actually, the exponent 3 only puts the 3 zeros there. Plus 500 ohms for R2, plus 2.7K. Anytime you say K, it's exponent 3. Only puts the zeros there. Plus 800 ohms equals 5,000. So our total is 5,000, which is 5K ohms. So our total is 5K ohms. Remember, Ohm's law was E-I-R. So when you're trying to get voltage, you can cover E, and it's I times R. When you're trying to get current, you cover current. It's E divided by R. When you're trying to get resistance, cover resistance. It's E divided by I. That gives you R. Okay, so we're moving right along. Now we're going to get I total. E total divided by R total will give you I total. I total is the current running through that circuit. So we're going to take 25 volts divided by 5K. 5 exponent 3 will give you 5 milliamps. If there's a negative 3 there already, it's already in milliamps. So we put 5 milliamps. What's constant in a series circuit is the current. So the current is 5 milliamps. The current is the flow of electrons through the circuit. We use conventional flow, so it's always out the positive side of the battery, around the circuit, and back into the negative. That is the polarity of the circuit, which is the flow of the circuit. What's constant in a series circuit is the 5 milliamps, which is the current. So to get the voltage drops for each, it's I times R. So it's I times R to give you your voltage drop here. I times R to give you your voltage drop here. I times R to give you your voltage drop here. And lastly, I times R to give you your voltage drop here. Your voltage drops, R1, R2, R3, and R4, must equal the applied voltage. So if I have 25 volts going into the circuit, 25 volts must be dissipated between those 4 resistors. Now we have to get voltages for each of those resistors. We cover E. I times R gives me E. So I times R, E. So for each of these, we're going to do that. So 5 milliamps, exponent negative 3, times 1,000, which is 1K, equals 5 volts. So we have 5 volts here. For the next one, it's 5 milliamps, exponent negative 3, times 500 ohms, gives us 2.5 volts. 2.5 volts. The next one is 5 milliamps, which is the current, again, times 2.7K. Oops, what did I do here? That's okay. 5 milliamps times 2.7K equals 13.5 volts. So we have 13.5 volts. Last but not least is the 800 ohms. So 5 milliamps, exponent negative 3, times 800 ohms equals 4 volts. So now we have to make sure that all of our voltage drops equals our voltage source. So we just simply add them up. 5 volts plus 2.5 volts plus 13.5 volts plus 4 volts should equal 25 volts. So now we know that our voltage drops equals our total applied voltage. Next, we're going to do power for all of them. Do we have enough time?